Today, the M30 southern section endures a very high density of traffic, 300,000 vehicles per day, due to the confluence of the east-west and north-south traffic movements, and also the interconnection with the M40 Super-South junction. This density of traffic produces important retentions that seriously obstruct the flow in this area, and even cause alternative routes to be established through the city centre, which produce further inconveniences. As a result, the municipal government of Madrid, as part of the Madrid M30 road project, has planned an alternative route for the east-west traffic movements, M30 South Bypass, which by means of two almost parallel single-direction twin tunnels connects Santa Maria de la Cabeza Promenade with Mediterráneo Avenue, approximately 4,200 meters, allowing the separation of this traffic from the middle and long-distance movements produced from the South Junction. Each tunnel of the bypass houses in its 15-meter diameter section 3 lanes of traffic with their corresponding curbs and service pavements on both sides. Transverse communication galleries between tunnels for pedestrians each 200 meters and for vehicles each 600 meters. And 4 direct exits situated in the ventilation and tunnel boring machines' entrance shafts, along with all the conventional and special installations of advanced technology inherent to long urban road tunnels which endure high densities of traffic, information panels, ventilation, communications, fire detection and extinction systems, etc. For its execution and due to the complexity of the ground to pass through, the use of 2 earth pressure balanced tunnel boring machines has been foreseen, one in each direction, which by working simultaneously will be able to finish such a great project in 30 months. EPB tunnel boring machine in the Madrid M30 South Bypass. The EPB tunnel boring machines, along with the segment assembly system, have been clearly established in the last years as the safest system for the excavation of tunnels in soft, unstable or waterlogged soils, with even greater advantages when they are situated, as in this case, in urban areas with high density of traffic or under important buildings. Some of the most important elements which form part of an earth pressure balanced tunnel boring machine are the following: a rotating circular head equipped with different cutting tools for excavating the ground, an earth pressure chamber which is a basic element for working in EPB. 20 years ago this chamber didn't exist and projects with tunnel boring machines in unstable excavation phases were much more complicated. The thrust cylinders which supply the force necessary to make the machine advance. The screw conveyor, which permits the controlled extraction of the excavated material. A rotating segment erector for the placement of the ring which forms the tunnel lining. A muck transport system to the outside, which is usually a conveyor belt. And the backup, which houses the equipment necessary for the operation of the tunnel boring machine. Energy supply, muck removal, segment supply, foam or mortar injection, etc. All the mechanisms necessary for the cutter-head drive and the thrust operation of the tunnel boring machine are installed inside a cylindrical structure, which is called the main shield. For the assembly of the tunnel boring machine, a shaft, designed especially for this purpose, is prepared, or an existing infrastructure is used where the machine is assembled and adjusted. Equally, a reaction structure is built to which the necessary forces for the initial thrusts are transmitted until the tunnel boring machine's advanced thrust force is counteracted by the weight and friction of the first assembled rings in the tunnel. The excavation begins with the rotation of the cutter head. The mechanism that makes it turn, also called the motorization, is formed by the main bearing and the gear reducers, which transmit the torque necessary for the material excavation and the mixing of the soil inside the earth chamber. For EPB tunnel boring machines, this torque is very high, reaching values greater than 85,000 kilonewtons meter for shields of slightly more than 15 meters in diameter. In this machine, the bearing of more than 8.7 meters in diameter is formed by the following elements: 3 rows of rollers capable of supporting the axial and radial loads and those produced by the turning torque, which act on the cutter head during the excavation and advance. These loads are usually very significant in EPB tunnel boring machines. The external ring gear with the main crown machined into it, on which 28 pinions mesh, each with a gear reducer and driven by electric motors of variable speed. And the necessary drive chain, able to transmit to the cutter head a nominal torque of 85,700 kilonewtons meter and a breakout torque of 127,000 kilonewtons meter, comprising the following parts: 28 electronic variable frequency units that regulate the rotation speed of the 28 electric motors. The power produced by these motors is transformed by 28 gear reducers. These reducers drive 28 pinions, each one with 16 teeth. These teeth turn the main bearing gear crown of a pitch diameter of 8.64 meters with 270 teeth machined into the external ring. The bearing is protected by 2 sets of seals, one internal and the other external, each formed by 3 rows of 4-lip seals and 2 rows of 1-lip seals. Their arrangement, together with their corresponding spaces, forms 4 chambers that avoid the ingress of external materials, such as water, sand, etc., to the bearing. The friction rings over which the seals slide are refrigerated by water to increase their durability and efficiency. The whole of this unit, called the motorization, is the basic part of the machine whose calculation, dimensioning, and manufacture almost reach the technological limits of the manufacturers of these components. Nowadays, bearings of nearly 8.73 meters in diameter are manufactured, capable of withstanding axial forces of up to 340,000 kilonewtons. The cutter head rotates in both directions and has a large number of cutting tools whose design depends on the ground to be excavated. It also has some overcutting tools with automatic control of their hydraulic operation, which are used to rectify possible deviations in their trajectory, to negotiate curves in extreme situations, or in the case of shield blockages. The cutter head has at its center a rotary joint with passages through which are supplied foam, water, bentonite, and other chemical additives that have to be injected into the excavation face in order to facilitate the treatment, support, and mixture of the soil. The material excavated by the cutter head passes to an earth pressure chamber where it is mixed by a central 3-armed earth agitator of 5 meters in diameter. This material is previously stirred by agitator bars situated inside the cutter head itself and on the bulkhead. All these provide a very homogeneous muck mixture which facilitates its fluid extraction. This earth pressure chamber maintains at all times a controlled pressure produced by the entry and exit of the soil to the chamber. The ground pressure is continuously measured by means of 8 pressure sensors. This chamber makes it possible to obtain an artificial support of the excavated soil, which allows the control of possible surface settlements as well as sudden ingresses of material. All of this is due to a precise control of the pressure in the chamber, determined by the speed of advance, the cutter head rotation speed, the addition of foam, bentonite or chemical additives. And the screw conveyor rotation speed. The extraction of the soil from the earth chamber is made by a screw conveyor. It consists of a helix which is supported at one end, the other is floating, and is driven by several hydraulic motors through their respective gear reducers. The muck is led to an adjustable gate where it exits to a conveyor belt which transports the extracted excavated material. It takes the muck from the screw conveyor to the backup, where it is transferred to another belt, installed along the tunnel, which takes it to the tunnel entrance. Once the precise length has been excavated, it is necessary to place one ring of segments. They are transported forwards by trolleys. The ring formed in the tail of the tunnel boring machine serves as a lining for the tunnel and, at the same time, as a reaction element for the advance of the machine. The segments are placed by a rotating erector to which the different segments that form one ring are supplied, one by one. The erector places the segments at the same time that the propulsion cylinders are withdrawn, thus putting each segment in its place and forming a complete ring. An innovation of this tunnel boring machine that will excavate the south bypass tunnel of the M30 is its double erector, which can place segments with one or the other table, thus optimizing the time for ring placement and improving the productivity of the excavation and the placement of ring cycle. The segments are made of precast concrete with polypropylene fibers and are joined together and to the previous ring by bolts and other fixing elements, and also to the ground by the injection of mortar between the ring and the excavated section. Once the ring of segments is placed, the machine begins a new advance. This is provided by the thrust of 57 hydraulic cylinders called main thrust cylinders, which transmit this thrust to the excavation face through other ones called articulation cylinders, which are 46 hydraulic cylinders located between the front and tail shields, and permit the excavation of curved paths with a minimum radius of as little as 350 meters. This kind of articulation, called active, permits the thrust cylinders to work perpendicularly to the segment ring and thus parallel to the shield, preventing rolling of the machine. The thrust force developed by the tunnel boring machine of 28,236 tons, besides making it advance during the excavation, also has to counteract the forces produced by the pressure in the chamber when it works in EPB and the ground friction forces, and also tow the gantries of the backup along the segment rings. This excavation method, computer automated and laser controlled, permits an exact excavation as well as the total control of the advance cycles, obtaining important performances, both qualitative and quantitative, as well as high excavation security rates, unthinkable for other excavating systems. The constant and everyday more efficient use of this mechanical excavation process in numerous infrastructures confirms the EPB tunnel boring machine as one of the most effective and secure tunneling excavation systems. With this intervention, together with the other operations included in the Madrid M30 road project, the municipal government of Madrid expects to unite a city which at present is divided by the M30, reducing at the same time accidents and contamination, both environmental and acoustic, enlarging the green zones and giving the Manzanares River the protagonism which it deserves.
Un vídeo realizado por Proin 3D.